So students, welcome again. In the session we were doing transpose of a matrix, and then we did about symmetric and skew-symmetric matrices, and in the last slide we have solved the example for what if we have given any matrix, it is a square or rectangular, from a given matrix how we can construct a symmetric matrix. That is, if we multiply a matrix A with its transpose, the matrix so obtained is called a skew-symmetric matrix. Let us take another case. Let A is equals to this matrix. It's a matrix of order 2 by 2, and of course it's a square matrix. Then show that A is equals to 1 upon 2 A plus its transpose plus 1 upon 2 A minus its transpose. So what does it mean? It means a matrix A can always be written as C 1 upon 2 A plus AT plus 1 upon 2 A minus AT, right? Before solution, let us see what I am doing here. If you open this A can be written as 1 upon 2A plus 1 upon 2A transpose plus 1 upon 2A minus 1 upon 2A transpose. So this and this will cancels out. What is left? A is equals to 1 upon 2A plus 1 upon 2A, and this is what? This is A is equals to A, right? Clear? This means what? This means a square matrix A, square matrix. Now be careful. I am mentioning here very strictly. A square matrix A can be decomposed into two parts. Part 1 is this 1 upon 2 A plus AT, and part 2 is 1 upon 2 A minus AT, right? And from this equation or from this exercise, we can see that a matrix A is equals to itself. It shows that we can always decompose a square matrix into sum of two matrices. Part 1 is symmetric and part 2 is skew-symmetric. This is the beauty of every square matrix. And this result is true for every square matrix, whether the matrix is of order 2 by 2 as well as of order 3 by 3. Let us see how does it work. See, what you want to calculate, you have given a matrix A, simply find out its transpose AT. Try to solve the question yourself now. A is given to you, find out its transpose. Add up the two matrices 1 upon 2 A plus AT. Now divide this matrix by 1 upon 2, you will get part 1. Likewise, A is there, AT is there, find out A minus its transpose, right? And then divide it by 1 upon 2, you will get second part. Add up part this and part this, you will get the matrix A itself, right? See, how does it work? A is this matrix given to you, right? Its transpose is very simple, rows and columns should be interchanged. Now, 1 upon 2 A plus AT. First find out A plus AT. You can find out A plus AT and then divide it by 1 upon 2. There is no issue. 1 upon 2 is written outside. See, A plus AT is what? A plus AT. Let me explain one, then you can proceed yourself. What is A? A is this, AT. 3 plus 3, this is 6. 5 plus 4, this is 9. 4 plus 5, this is 9. 3 plus 3, this is 6. Right? Okay? And what is 1 upon 2? A plus AT. See what happens. This means divide this matrix by 1 upon 2. So 6 divided by 2, that is 3. 9 divided by 2, that is 9 by 2. Again 9 divided by 2, that is 9 by 2. And 6 divided by 2, that is 3. So this is the matrix 1 upon 2 A plus AT. 3, 9 by 2, 9 by 2 and 3. And you can check. This is a symmetric matrix. Find out its transpose. If you take the transpose of this matrix, its transpose will remain the matrix itself. Therefore, this is a symmetric matrix. It's your duty to verify whether this matrix obtained is symmetric or not. Right? Likewise, find out A minus AT. Right? A minus AT, and then divide it by 1 upon 2 or multiply it by 1 upon 2, and then simplify it, see you will get a new matrix that is 0, 0, 1 upon 2 and minus 1 upon 2. If you recall the definitions of symmetric and skew symmetric matrix, this is symmetric and this is skew symmetric, right? So 1 upon 2a plus at, this part represents a symmetric matrix, and 1 upon 2a minus at, this part represents a skew symmetric matrix. And if you add up these two matrices, means this 3, 9 by 2, 9 by 2 and 3, if this is symmetric, if this is added to 0, 1 by 2, minus 1 by 2 and 0. See what will happen. 3 plus 0 is 3. 9 by 2 plus 1 by 2, that is 10 by 2. 10 by 2 is 5. 9 by 2 minus 1 by 2 is 8 by 2. 8 by 2 is 4. 3 plus 0 is 3. What is this? This is your matrix A, right? So this example actually shows what? Every square matrix of any order can always be decomposed into two parts. Part 1 is symmetric and part 2 is always skew symmetric, right? Let us have the same example for a matrix of order 3 by 3. We will use the same approach as we did in case of a matrix of order 2, right? Let A is equals to this. This is a matrix A. Find the matrices x and y such that x plus y is equals to A. Clear? But this question refers to where x is symmetric and y is skew symmetric matrix, right? A matrix A must be written as a sum of these two matrices x and y, right? This x is symmetric and this y should be skew symmetric. Clear? What does it mean? It means the matrix A can be decomposed as sum of x plus y, where x is symmetric and y is skew symmetric. It's a verbatim exercise what we did in the last exercise, that is example 2. Means decompose the matrix A into sum of two matrices, one is symmetric and other is skew symmetric. Clear? See, let A is the matrix given to us. This is matrix A. Now find out its transpose. This is A transpose. Hope you understand the concept of transpose. I don't need to explain it many times. Say A is this. Let us say AT. How we will calculate? A transpose means the first row 3 2 7 should be the first column of A transpose. Second row 1 4 3 should be the second column of AT. 1 4 3. Minus 2 5, the third row of A must be the third column of AT, that is minus 2 5 and 8. This is your transpose, right? This is your transpose. Now add this A plus AT. How you will add up? 3 plus 3 is 6, 2 plus 1 is 3, 7 minus 2 is 5. So 6, 3, 5. Add up the two matrices. Addition of two matrices means add their corresponding elements, right? So A plus AT is this matrix. Now A plus AT, this we have calculated. If we take its transpose, so what we are getting? We are getting the same matrix A plus AT. It means A plus AT is a symmetric matrix. So this is a symmetric matrix. A plus AT, its transpose is coming out to be A plus AT. Thus A plus AT is symmetric, right? A plus AT, don't be confused. A plus AT is a matrix. Say you take, understand like this, A plus AT. If you take it as C, so C is what? C is this matrix. 6, 3, 5, 3, 8, 8, 5, 8, 16, right? So A plus AT, its transpose means transpose of the matrix this. So what you will get? 6, 3, 5, the first row should be first column, second row should be second column, third row should be 5, 8 and 16, right? this and this both are same. So A plus AT transpose is giving you A plus AT itself. So A plus AT is symmetric, means the first part is symmetric. Now again A is this, the transpose we have already calculated. Now take the difference of these two, A minus AT. A minus AT is coming out to be this matrix. Again check A minus AT is symmetric or skew-symmetric. So A minus AT transpose is coming out to be minus times of A minus AT. That is, A minus AT is skew-symmetric. So this shows that A minus AT is skew-symmetric. So what we did, A plus AT is symmetric, right, and A minus AT is skew-symmetric. Now you can multiply this by 1 upon 2 and this by 1 upon 2. We are given x is equals to 1 upon y. So if we take x is equals to multiply A plus AT by 1 upon 2 and A minus AT by 1 upon 2, sum of these two, you will get the matrix A itself. So if x is this matrix and y is this matrix, then x plus y will give you the required matrix A. So what actually we conclude from these two examples? Number one, in case 1 what we did, if A is any matrix, then A of AT and AT of A both are symmetric, right? Symmetric matrix. So this example shows you what, if you have given any matrix, whether the matrix is square or rectangular, find out its transpose AT, and if a matrix A is multiplied with its transpose AT or AT is multiplied with A itself, in both the cases the matrix obtained will be a symmetric matrix. This is what we conclude from exercise 1. What is exercise 2? Exercise 2 is this, if A is any matrix, but now the condition is what? A should be square. Clear? The basic difference between example 1 and example 2. Example 1, A may be square or rectangular, but in case 2, A is a square matrix, then A plus AT is symmetric, right? And A minus AT is skew symmetric. Clear? If A is a square matrix, find out its transpose, add A and AT, you will always get a symmetric matrix. Take the difference of A and AT, you will always get a skew symmetric matrix, right? So this is what we conclude, how we can construct symmetric and skew symmetric matrices from a given matrix, right? Let us take this example also. Find the values of x and y if the matrix A is equals to this, 1 upon 3 times of this. Satisfies the condition A of AT is identity, where I3 is an identity matrix of order 3. See this, you have given a matrix A, this is your matrix. What the question say, question actually refers if A is a matrix and AT is its transpose. What is given, A of AT is equals to identity matrix. Then find the values of x and y. Hope you understand the question. Clear? A matrix is given to you. You have to find out the values of x and y. See, this is x, this is y. They are the elements of the matrix. Clear? What is given here? You have given if a matrix is multiplied with its transpose, the product is an identity matrix. This is the condition which is given to you. Now, very simple, A is given to you. Simply write down its transpose, AT, then multiply the matrix A with its transpose, AT. It must be equals to identity matrix, right? If the product of A and AT, it will be a matrix, and this matrix will be equals to identity matrix, and we know the condition of equality of two matrices, that is, two matrices are equal if their corresponding elements are also equal besides their order, right? Two matrices are said to be equal if they are of the same order and their corresponding elements are equal, right? So we will use this property of matrices to find out the values of x and y. Let us see how does it work. A is a matrix given to you, right? This is your A. A is 1 upon 3. See 1, 2, x, 2, 1, 2, 2, minus 2 and y. This is your A, right? Now, very simple, write down its transpose first. So, what is AT? AT is the rows and columns should be interchanged. The first row should be converted to first column. 1, 2, 2, 1 upon 3 will remain as it is, right? This is outside the matrix. Second row is 2, 1, minus 2 converted to the second column, and third row to the third column x, 2 and y, right? AT is there. So, very simple, this is A, this is the transpose of A. Now, what is given to you? We have given A of AT is equals to identity matrix, say A of AT, multiply A with its transpose, you will get the resultant matrix, and that matrix should be equals to identity matrix, right? Now, see, this is if A and AT, if you will multiply this 1 upon 3 and 1 upon 3, you will get here 1 upon 9, right? Write down here A, here AT, and then multiply them, right? This is 1 upon 9, this is A and this is AT. And you know how the two matrices are multiplied. The rows of the first matrix should be multiplied with the columns of the first matrix. Be careful, right? So 1 upon 3, 1 upon 3, you will get here 1 upon 9. See, let me explain one term only and the rest you can do yourself. The first row of the first matrix is this 1, 2, 2. This row should be multiplied with the first column. See what you will get. 1 into 1 is 1. 1 into 1 is 1, 2 into 2 is 4. So 1 plus 4 plus 2 into 2 is 4. So 4 plus 4, 8, that is equals to 9. So 9 is the first element, right? Now the first row should be multiplied with the second column. Clear? 1 into 2 is 2. 2 into 1 is 2. 2 into minus 2 is minus 4. So, this is what? 4 minus 4, this is 0. So, 0 is second element. Clear? Now, take the third. The first row should be multiplied with the third column. 1 into x is x. 2 into 2 is 4. So, x plus 4. 2 into y is twice of y. So, what you will get? X plus 4 plus 2y. We are getting the same term x plus 4 plus 2y. This is how we can find out the product of A and AT, right? Similarly, or in a similar way, take the second row of the first matrix, this, multiply with the first column, then multiply with the second column, and then multiply with the third column. You will get 0, 9 and the second row twice x minus 2y plus 2. Clear? You will get the second row. And likewise, take the third row, that is x2 and y. x2 and y. Clear? Multiply this third row with the first column and then second column and then third column. You will get x plus 4y plus 2y, twice x plus 2y minus 2y, and x square plus y square plus 4, right? See, let me explain the third row. Second row is very easy. What about third row? Third row is x2y. The third row should be multiplied with the first column of the second matrix. So see, x into 1 is x plus 2 into 2 is 4 plus y into 2 is twice of y. So what we will get? X plus 4 plus 2y, x plus 4 plus 2y. Clear? Now the third row should be multiplied with the second column, this column, right, this one. X into 2 is 2x, 2 into 1 is 2, that is 2x plus 2. X into 2 is 2x, 2 plus 1 is 2, and third is y into minus 2 is minus 2y. So this is second element, twice x plus 2 minus 2y, we are getting the same. Now the third row should be multiplied with the third column, right, this column last. X into x is x square, 2 into 2 is 4, y into y is y square. So what we will get, x square plus y square plus 4, we are getting the third element, right. So this is how we can multiply these two matrices to get its resultant matrix, right. Now after getting the resultant matrix, what is given here, this matrix is what? This matrix is A into AT, and this matrix is equals to identity matrix, right. So look at the next line. Since AAT is equals to I3 is an identity matrix of order 3. This is given to us in the question. So A into AT, we have obtained the product of A and AT. So this matrix should be equals to identity matrix. See, this is the matrix of the product A and AT, and this is your identity matrix. Clear? So these two matrices are equal, and you know that equality of two matrices gives you what? Two matrices are said to be equal if their corresponding elements are equal besides their order. So order of both matrices are same, both are of order 3 by 3, because the first matrix contains 3 rows and 3 columns, and the identity matrix also contains 3 rows and 3 columns. So now what is left? We will equate the corresponding elements of both the matrices to get the values of A, B, C. See how we will equate the elements. 9 is but we want to calculate the values of x, y, z. See, x plus 4 plus 2y, x plus 4 plus 2y, these two elements are same. Twice x minus 2y plus 2, twice x minus 2y plus 2, and this is x square plus y square is equals to 4. So we can equate either the elements of the third row or elements of the third column because they are same, right. So what does it mean? It simply means the first equation is what? Say x plus 4 plus 2y is equals to 1. X plus 4 plus 2y is equals to 0. Say 1 upon 9 is also there. This is equals to 0. This is equation number 1. Equation number 2 is what? 1 upon 9 twice x minus 2y plus 2. This is also equals to 0. And third is x square plus y square plus 4. This is equals to 1. So these are the three equations we obtain. Now from these three equations we will find out the values of x and y. See, this equation 1 can be written as x plus 2y minus 4, because 9 will be transferred from left hand side to right hand side, it will be 0. So x plus 4 is plus 2y is equals to 0. This can be written as x plus 2y is equals to minus 4. Likewise equation 2, this can be written as twice x minus twice y, this is equals to minus 2, right. So this you can divide it by 2, what you will get, or don't divide. So these are the two equations. Third is x square plus y square plus 4 is equals to 1. Now solve equation 1 and equation 2 to find out the values of x. How you will find out the values of x? If you simply add equation 1 and equation 2, see what will happen. X plus 2y plus 2x minus twice of y minus 4 minus 2 minus 6. This will cancels out. Twice x plus x, 3x is equals to minus 6. So this implies x is equals to minus 2, right. X is coming out to be 2. Now put the value of x in either equation 1 or equation 2. You will get the value of y as equals to minus 1. So x is equals to minus 2 and y is equals to minus 1. These are the two values of x and y which we obtained from equation 1 and equation 2. But here we are having three equations. So what about equation third? If this x minus 2, y minus 1 is the solution of these three equations, then it must also satisfy equation number 3. Now see whether this equation is satisfied or not. X square plus y square plus 4 is 4, this transfer this type, that is equals to 3, this is equals to 0. X is 2, 2 means 2 square means 4 plus minus 1 square means 1 plus 3, this is 0. So 4 minus 1, 3 minus 3, sorry, 4 minus 1 is 3, this is minus 3, minus 3, so 3 minus 3 you will cancel out, you will get here as 0, right. So it shows that x is equals to minus 2 and y is equals to minus 1 satisfies all the three equations. Therefore, the required values of x and y from the given matrix are 2, minus 2 and minus 1. So this is how we can calculate the values of x, y, means the elements of a matrix using the given conditions of transpose of a matrix. So this is all about the content of the symmetric and skew symmetric matrices. So students, I think I should stop it here and I will continue the remaining text in the subsequent text. Thank you very much.